So, guess we can, we'll start. I guess we can have it all. Okay. Let's see. What was the first set of functions that we talked about in here?
R to R2.
R to R2 and
R to
R to R2, R to R3. So, what letter did we usually use for these? R, right?
R.
And I want you to know that because all of this is on the test, right? When you see a R, I want you to think it's a parameterized something. If it has one parameter, it's a parameterized. If it has two parameters, it's a parameterized. So if it has one parameter, which is what you just said, what does it look like?
Curve.
It's curved because it's one-dimensional. If it has two parameters, then it's a parameterized surface. Right? But in both cases we use. All right. But in this case, so as always with everything, we look at the algebra. R of t equals x of t, y of t, z of t. And I'm just going to generalize this as if for two dimensions, what would this be?
0.
0. It would all be happening in the plane. So we looked at the algebra. This is how you write this algebraically. And what was the first question you ask yourself whenever you look at a new function? Is this what?
Units.
Domain. So we do that. And the geometry, just like we said, this is a curve that lives in space, or the plane, I should say parametric. Parametric curve lives in the plane or space. So after we did algebra and geometry, what's the next thing we look at?
Calculus.
Which is, the first topic of calculus is?
Limits.
Limits. So if we want to take the limit as t approach some particular value, that is something in the domain, approach a particular value, how do we do this?
Component wise.
Component